SMOTE is a very popular oversampling technique that you must have heard if you haven't used it already. So it stands for synthetic minority oversampling technique. So basically, a naive idea would be in oversampling to replicate the given data set, just repeat it. But that won't be an ideal case, because in that case you are repeating, you are not providing variety to the model, and eventually the model may overfit on that data. So rather than just repeating the data set itself, we would try to generate some synthetic samples using the minority class samples that we already have. And in this, SMOT helps us a lot. It is a very popular algorithm. And now let's see how it works. So first of all, out of the entire minority samples that we have got, we need to randomly select one of the minority class instance. So this is for one sample generation that I'm talking about. Then we will be finding out its nearest neighbors from the same class. So for example, assume that we have picked up the random sample as this particular, the blue dot you can see. This is assume that this blue class is a minority class. Now, if we are picking up this blue sample, so we would be picking up its nearest k neighbors from the same class. So assume that k equals to 3. In that case, we would be picking up the nearest 3 samples. So that can be this, and this for this particular sample. I hope this is clear. So we are picking up the k nearest minority class samples and then generating synthetic samples. So what we would be doing, we would be randomly selecting one of the neighbors and create a synthetic samples by interpolating between the original instance and the neighbor. So if you see, assume that this is the origin, this is the sample that we picked. We picked up its 3 k nearest neighbors, and out of those also, I have randomly picked up this particular point. If you can see, now how we would be generating a new sample? We would be getting a point between, if we form a line between these 2 points, any point that would be falling onto this line, we would be consider it as a synthetic sample generated. So it's nothing, it's quite easy to understand. You pick up a sample from the minority class, get its k nearest neighbors from the same class, randomly pick one of the nearest neighbors, and then interpolate a point. Basically, a point on the line. If we create a line between these 2 points, which point will fall on that? We can pick one of them. So if we start off by say non-fraudulent transactions 950 and fraudulent transactions 50. So fraudulent is the minority class here. So this may look something like this. We choose a fraudulent transaction, transaction A. We find out its nearest neighbors, say B, C, and D are its nearest neighbors from the same class. We pick up a sample, random sample B for now to interpolate a point. As I told you, from the nearest neighbors also, we need to pick up a random point out of these 3 or 4 samples that are present. Assume that point transaction A has a value x1 y1 and transaction B has a value x2 y2, the points I'm talking about. So the synthetic transaction that we would be generating would have a value x1 plus alpha into x2 minus x1 and y1 plus alpha into y2 minus y1. Very easy to understand. So this would be the equation that we would be following. Where now, after applying SMOT, the final sample may look something like this. The fraudulent class would also become 950 with 50 points original and 900 synthetic. So we would be repeating the above step, like pick up a random point, get its k nearest neighbors, pick up a random k nearest neighbor, and then interpolate a point 900 times, and eventually we will be getting our synthetic samples.